Here's my presentation for PID control system, especially for our device, our project device, which is a barbell tracking device. First, the introduction. And what is the system? A system is a interconnection of elements and device for a desired purpose, and a controller system is an interconnection of components forming a system configuration that will provide a desired response. As you see here, it is a aligned system. For the purpose, to start the purpose, we should have inputs such as bottoms, something that we set in for the system to start. After we set all these inputs, there is a controller, a system that will try to calculate what you want, and after that, after it's done, after the system is done, it will give us outputs, that things that we need. Process. The process is the device, plant, or a system under control. So we can control these process, how we want them, how we want them to start, when we want them to start, when we want them to end, give us what, and we can plug what we want on them. The input and the output. The process start with an input and give us an output. A relationship represents the cause and effect relationship of the process. Cause and effect. For there are two types of control system: an open loop control system and a closed loop control system. As you see here, there is no feedback for the open loop control system. We just plug our inputs, the controller will try to process and give us the output. But for the closed loop control system, we can utilize a feedback to compare the actual output to the desired output response. Like if we have a bottom here, we can press a bottom to start the process. After that, for the output, if there is something wrong, we can for the process, if we need to calculate some elements like power, anything, when it's to give us the output, it will give us a feedback that all your outputs are ready, and you need to stop the system. So we can press another button to stop our system. The device that I talk about is a barbell tracking device. This is a device that me and my friends try to do as a project for our class. The purpose of this device is a tracking device is to measure velocity, power, and power path. It's like a coaching for those who want to lift. For the embedded device is placed to barbell and use an internal measurement unit like IMU sensor to record acceleration data. We use an IMU sensors because they are capable to calculate the elements that we need, the power path. It will show us on another app phone. We also have an app phone for that one. After we receive the data from the IMU, after we finish the lifting, coaching lift, it will send us a data, and we gonna receive this data for on our phone app, because we also have a phone app for that one. But I don't think I need to present that one for here, because we just we just need the system, how it operates. It then display and calculate the velocity and maximum velocity, power, and power path. How is your lifting was a good lift or no? That will show on the phone app. We don't need that one. Here is our design for an example for control system. Here's the device. We set a button for that, like if we want to start the phone the if we want to start the device, we have a recording request, so we press a button. We can plug our how much the thing that we want to lift weight, and we need to do a physical movement like lift the bar or something like that. We have USB charger for our device to charge our device, because we have 3.7 voltage battery. So after it's dead, because the battery is just for 2 hours, after that we need to recharge it. After we do the request, we need the movement. That movement will happen. After that we can press it will give us a feedback. We need to stop it, and it's gonna give us the velocity, the power, and the power path. Here's our inputs. As you see, record request, weight, physical movement. The outputs as I mentioned before. Functionality, receive the recording request and being tracking device movement. As I said, the device is rechargeable via USB. We have USB for our device to charge that one. And here how the device and the phone app are connected with each other by IMU sensors. So after we do the request, we do the movement for the device, we plug our weight. It will send the bar weight for the app, how much is, and the IMU. We can plug our weight for how much we weight on the phone app, and after that the data will record, and after that the phone app will give us the outputs. This is the level 1. The first one was level 0. As I said here are inputs and outputs. Receive recording request on the device and track physical movement. The device, the IMU sensor, gonna track our movement. This data is processed to send a phone app for more processing and display. It will display the information you need on the phone app. We don't need that one. Here is a level 2 graph recording request. We are having a bottom here. We are having a USB charger here and the battery. State change the controller. It will gonna like go and for the will give us we need a physical movement to start the IMU, because without that we don't have enough data, so we need a physical movement. After that it will gonna send for the controller. The controller will send with the receiver. We need to charge them all by DC power battery. After that the transceiver will give us IMU data. This one is a closed loop system. As you see here, we need to go back and forth. It's not like a linear system that you just need to plug and that's it, because IMU data will just see your movement first, and then it's gonna record, give the controller enough data about that. The data gonna send to the transceiver, and after that will give us the IMU. Our recorder start when the microcontroller receives the request. So we need to the bottom that I show you, and the IMU data is gathering and processed, then sent the transceiver. That's it for here's the conclusion. We start with the introduction and then type of control system, the device that me and my friends designed, and the examples for the control system. We have closed loop system. That's it for here's our sources, and thank you.